Afternoon, everyone. Welcome to Automate Your Automation. My name is Greg Anderson, and you can see my Twitter handle right there, Greg_1_Anderson. If you go to Twitter right now, my last tweet has a link to the slides. You can follow along if you're so inclined. I'm an open source contribution engineer. I work for Pantheon Systems, and I also work on their back end as a platform structure engineer. I've contributed to a number of open source projects, including Drush, Robo, the consolidation tools, and a little thing called CGR, which you should learn about if you do command line tools. I'm going to talk about automation planning today. What is automation? Anything you do manually is subject to error and, quite frankly, the onset of boredom. So we want to eliminate boring tasks by automating it. And the way we're going to do this is just to examine what we do on a daily basis and start off by making sure that before you start automating, you make sure that your practices are good, because you don't want to automate bad results. That will just give you automated large volumes of bad results, and we want large volumes of good results. So once we know what we're doing, we're going to survey the available tools, we're going to automate it, and then we'll take a step back, look at how it's going, and repeat the process all over again. So what can be automated? Anything can be automated, really. Development tasks, testing, deployment, and maintenance tasks such as software updates are going to be the main focus of what we're looking at today. This is one of my favorite XKCD cartoons, if you measure favor in terms of how inclined I am to show this in presentations, which is in almost all of the ones that I do. This is a funny cartoon because it talks about the trade-off between how much time you spend making tools and automation versus how long it would take you to just do the task manually. It breaks the whole thing down, just like in computer science, just how often do you do it. And so he gives you a time budget. If you do it 5 times a day and it only takes you a little bit of time, that means if you can automate it, your time budget is like 30 minutes. And this is kind of a funny cartoon because we're used to the opposite situation where you have the guy and he's in the forest and he's got his axe and he's trying to chop down all the trees. He says, I just can't get through all of these trees. There's so many trees. Someone comes up and says, why don't you sharpen your axe? He says, I can't. I don't have time. I've got too many trees I got to chop down. But this is the opposite joke. This is about the engineer who spends all of his time sharpening the axe, and when his manager comes by and he says, how's that tree chopping going? And it's like, the tree chopping is way ahead of schedule. I haven't chopped any trees, but my axe is super sharp. I'm just going to keep sharpening it. But you can't fall into this time budget too much. You want to be aware of it so you don't become that guy who's always sharpening his axe. But the benefit of automation is greater than the simple sum of how much time you're going to spend on it. When you automate, your processes are going to be more reliable and repeatable. It's going to be easier for you to bring new people into the organization. And your improvements are going to compound over time. So if you look at your time budget in the beginning, you might say, once a month I bother to check and see if I have any critical software updates that I need to make. But if it's automated, you can do that more often. So your efficiency becomes greater. And you can add improvements on top of your improvements. The alternative is to not automate. And there's a hidden cost in that. If you just look at the time budget, where you're doing the same thing over and over again, when you do the same thing repeated times, it gets boring, and you're more likely to gloss over it and maybe make mistakes. You have a large risk of lost knowledge. If you don't do something very often, maybe you don't automate it because you think, I hardly ever do that. But then 6 months go by and you say, wait, I forgot how to do it, and now it takes you longer to do it. And the more you do this, the more your deferred maintenance can pile up, and this can lead to discouragement, and it can lead to some really undesirable effects inside of your organization. Recently, there was a very interesting pair of articles that came out in the blogosphere about this top talent controversy. And there's a blog about a really bad situation, and the author said, oh, it's the employee's fault. And there's a follow-up blog that said, oh, it's the manager's fault, and I shouldn't have let the situation get so bad. I've got the short URLs to these articles. If you haven't seen them already, you should go and read them, because they're an interesting read, and they talk about a situation that happens all too often in the industry. And the thing I wanted to call out here is, in this article, this engineer who they described as both their top talent and the guy who they saved their company by firing him, even though he was a good worker, he had his product's production environment completely replicated in his office, and he would test his software on the clone of this completely replicated system. And most of us in this room work on Drupal, and so we're lucky because Drupal's already been designed to be easy to install, and it's easy to make copies of Drupal sites. But I've actually worked in large companies where it was not uncommon for products to grow out of control like this, and it was so hard to install that there might only be 1 or 2 copies of the whole system, and you just couldn't test it in isolation. So a warning sign that you're behind on your automation is when it's hard for you to bring in new people and it's hard for you to replicate your environment, so you can't do your tests. So you want to get things going before you get to that step. So that's the background, and what I want to talk about in this session is some of the tools of the trade, how you can automate. Because most of us are familiar with PHP Unit and Travis and Circle, and I've given a talk in the past where I survey some of the available tools online. But as great as these tools are, it takes time to set them up. And the more time you spend setting them up, the longer it's going to take you to get to that payback point in the XKCD cartoon where you're saying, how often do I do it and how long does it take? So when you have a lot of projects and you have to go through this setup step a lot of times, you can make your life a lot better by automating your automation. I'm going to talk a little bit about some service APIs that are available. Many of the services out there have APIs that allow you to remotely manipulate them, and we can do things like automatically create pull requests, post comments, set up your test system, and respond to other events using webhooks. For example, in GitHub, we've got a easy way to make a pull request. All you need to do is create a new branch using Git and then make the PR. And you can either use the Hub tool, which is a command line tool you can easily download and install, or utilize the REST API for GitHub. I'm sure most of you have used Git before, and you're very familiar with creating a new branch and pushing it up to your production system. But when you do this as an engineer, you're authenticating with GitHub using an SSH key, and you've set that up manually one time, and then you don't have to worry about that very much. If you're automating this, it's less likely that you're going to want to use an SSH key. That's kind of a bother to set it up. Also, in your local environment, you have a remote setup that's pointing at GitHub. Maybe you don't have the remote set up in your automation. So there's another form you can use to push the remote up. If you, instead of naming a remote, you can give the entire URL to the repository as a parameter to your Git command. And I just noticed that that should, of course, read git push, not simply push, on the bottom line of the slide there. And in addition to pointing at the repository, you can also use the XOAuth basic form, where you simply put the contents of your OAuth token into the URL, and that's going to go up and create the branch on GitHub. The Hub tool comes in pre-installed packages available for macOS, Windows, and Debian, and once you've installed it, you can simply run hub pull request, give it a comment, and before you know it, you will actually have a pull request up on GitHub. And I'll show you a number of ways where it's really useful to have scripts that will create pull requests for you as part of your automation workflow. It's also possible, if you don't want to use the hub tool for some reason, to just talk directly to the GitHub API. And this little bit of code here shows how to use Guzzle to talk to api.github.com. And I'm just going to sort of gloss through it. It has some headers that say, hey, we're going to talk in JSON, and you throw in your authorization token, which once again is an OAuth token. And with a simple request, you'll get some JSON back, and the end result is the same as if you use the hub tool. And this might be a good option if you're using Circle version 1 and you don't want to install extra tools. Here's the code that actually creates the pull request using the function on the previous slide. You just provide the name of your organization, which is often your GitHub username, and the repository. And down there next to head, I've highlighted forked repo. That's the format that you use if you're making a pull request against the fork, but you just leave that and the colon off if you're posting directly to the primary repository. It's also very interesting and useful to make comments on your pull requests. If you're doing this in person and you're commenting on your coworker's flying machine project, you might ask him some questions like, are you sure this is going to fly? Are the mock tests passing? And is anyone really willing to get on this thing and try it in production? Similarly, when you have automation tools, you might want to post the status of some test results in the same way that Circle and Travis do, and that is easy enough to do with the REST API. Unfortunately, the hub tool does not have a command to add a comment to a pull request, but you can see at the bottom of this slide there's a URL to a pull request on the hub tool that starts to do this. If anyone's really motivated and knows how to write in code in Go, you might want to push that along a little bit. But the REST API looks very similar to the previous example. You attach the commit to, or you attach the comment to some SHA1 commit and just provide the text for the comment in the body. And the little icon for the user next to the comment is going to be the user that you used to create the OAuth token when you logged in. It's also possible to configure test credentials on Circle CI and Travis using either the REST API or a tool. Here's an example of the Circle CI REST API. You might want to look at the slide more for reference, but basically what we're doing here is we're setting an environment variable. So whenever your tests run, you'll have a certain set of environment variables available. Often you'll want to put OAuth tokens into your tests if you have a test that needs to communicate with another system. One example of this, of course, is if you want to be able to post a comment back to a pull request, you're going to want to have an OAuth token for GitHub available to Circle so that that tool can run. And I've also noted here that if you're using the web interface for Circle, it shortens GitHub to GH, but if you're using the Circle API, you have to remember to spell it all out as GitHub. That's an inconsistency that'll give you a 404 if you get it wrong. Travis is kind enough to provide a CLI tool that does all sorts of things. Creating comments is only one of the things that's available. It has installation mechanisms for Mac OS, Windows, and Debian, like the other tools that we saw earlier, Hub. And you just run Travis mset, name the token, and it goes. And I strongly suggest if you're using Travis that you just use the tool regardless, because while it is possible to use the Travis API to do all of this, it's a little bit unfriendly. It does not have an easy OAuth API. You have to do like a two-stage authentication with GitHub in order to get another token. And I, for one, have never bothered to do that because I didn't feel like my time budget really justified it when I can just install the tool. Spinning up new projects is something that's really easy to do with Composer. If you've started to use Composer for managing your Drupal sites or other projects, there is a command called create project, and it also has the capability for you to add things onto it with some post create scripts. So Composer create project will take an existing template project you have and make another copy of it, and it renames everything and sets it all up so you have a brand new project that's now orphaned from the one you created. Now, if your original template project has changes in it, it is possible for you to bring those in. All you would need to do is clone your new project down, set a new remote back to the origin, and then you can pull from the origin and merge the changes in. But usually, when you're following this workflow, you just orphan the original, and now you have your own project that can evolve at its own pace. The dependencies of your project you'll keep in your Composer JSON, and you'll update those via Composer update as usual. So a very successful strategy that can be employed in the template project is if you have any functionality in the template that you think might be evolving over time, you should factor it out into its own project so that you can add it to the Composer JSON, and then the children projects can be updated with a simple Composer update. Composer also has create project scripts, or post create project scripts, or they're actually post update and post install scripts. If you are familiar with running a Drupal site managed with Composer, you may be using the Drupal Composer Drupal project example already, and it uses a tool called Drupal Scaffold that will automatically fill in some of your base files from Drupal.org or another source. And this is an example of using post-install and post-update scripts. You can take a look at the project for Drupal Scaffold if you want to see an example of how that's done. Testing practices. As I said at the beginning of the presentation, it's really important to have a process that's good before you start spending a lot of time on automation. So I want to talk a little bit about testing. The best thing that you can do is write testable code. And how do you write testable code? Well, the most straightforward way is you write a method where you pass values to the functions, and that function should return values. And if you have all of your code expressed in this functional way, it becomes very easy to write unit tests. Now, obviously, you can't always do that for some systems. So there are two basic techniques that you can use for those portions of the code that are not easily testable. And one is functional testing. And in functional testing, you stand up a working system to test against. And in this model, it's usually pretty easy to write tests. A lot of people use bhat, and you can use a syntax called Gherkin, which is very English-like, and you can just start recording tests that test the current state of your project. But the downside of this is it's sometimes hard to maintain because false failures might creep in. If your test is checking for a very specific thing and the product design evolves, so that specific thing is slightly different, then you'll get a failure. But it's usually not a difficult matter to fix those up when they creep in. And the other thing about functional testing is it takes longer to run. And this causes sometimes the effect that people will want to avoid functional testing and maybe move on to a different technique like mocks. A mock replaces an actual system with a copy or a stand-in. And mocks are very, very useful for providing values and getting results back. Like, for example, if you had a little plug-in to a web server, you might mock the request and response objects so you could pass values into your system and not actually have to have a running web server. The downside of mocks, though, is that, again, these can be hard to maintain, but in a completely opposite way of functional testing, in that false passes can creep in if the real underlying system that you're mocking changes, so its behavior is different, but your mocks still behave the same. Your tests are all going to pass, but it doesn't actually work with the actual system. So it's best to avoid using mocks for the interior of your function. Use them for objects that are coming in or collecting objects that are coming out the end. But if you replace too much of the function, you're not doing adequate testing. You should really consider that anything that's mocked is not tested. I've seen people who want to try and get their test coverage scores up very high to mock every single function. So you have a function that calls A, B, C, and D, and then they mock all four of those things, and all they have really tested is that this function was implemented by calling A, B, C, and D. And you're only testing the implementation, not the behavior, and there's no value for that. Another really cool thing that you can do is leverage Docker. I've recently started using Circle 2, which makes it really easy to use Docker containers. On a typical Circle 1 setup, at the beginning of your test run, you install all of the tools you need in order to test. But with Circle 2 and Docker, it can be a lot faster. If you simply put the tools you need into a Docker container, then Travis is going to pull the whole Docker container down and it'll cache it, so you don't have to reinstall those tools every time. It makes your tests run a lot faster. So it's possible to automatically rebuild your Docker image whenever your source repository changes. This slide is showing a configuration setup for Circle 2.0, and the first line there says that I'm going to pull an image off of Quay, and Quay is a service where you can put Docker images, and they have a free tier. A lot of times people are using Docker Cloud, which is the recommended or standard, I guess you would call it, repository. It also has a free tier, and if you're using Docker Cloud, then that first, everything up to the first slash just disappears, and you just give the org name and the project name. But I wanted to call out Quay because it's easy to drop in a third one if you don't want to use Docker Cloud for some reason. Docker images are easy to create. You just make a Docker file, and you can see here that at the beginning it has a from line, and that just gives you the name of some other Docker file that you're going to use as your base. In this case, Drupal Docker has a simple container that just has PHP with the CLI in it, and so I'm using this to run some tests that are mostly just using PHP CLI tools. The other technique that I use here is I've created a folder called Build Tools CI, and on the third line we just add that. Everything in your source repository in that folder will then be copied into the Docker container, and for my scripts or for my test systems, I'm putting these scripts and making them live with the Docker container, because the script is going to set up the test environment with the environment variables and setting up the path and the tools, and what those scripts need to do are directly tied to how the Docker container is set up, so it makes sense for those to live together. And then at the end, there's just a sequence of run commands, and this is just like a bash script. Every line will just implement or just execute the tool that you name, and so we're installing a few tools, such as, in this case, Drush and Prestissimo, which is a tool that makes Composer run faster, Composer installs run faster. Here is how you can set up a system with Quay to automatically rebuild your Docker container anytime the sources on GitHub changes. And you can also do this with Docker Cloud, but on Quay it's kind of neat because it's just a one-stop shopping. When you create your repository, the automation to link to a GitHub repository push happens right at creation time, and those are extra steps on Docker Cloud. Deployment. It's also possible to automate releases with Travis, and I'm going to show you a little bit about how to do that and also how to do a self-update for tools. The Travis tool can be used to automatically set up something to include a releases section, and the releases section on Travis will take a build result such as the Phars for a command line tool and copy it up to GitHub. And it turns out that you don't have to worry so much about automating that step yourself because the fine people at Travis have already done it for you with this Travis setup releases command. If you provide a OAuth token as is shown in red, then it will authenticate against that OAuth token for you and set up your releases section. But if you leave that off, it's going to prompt you. The yellow text will disappear if you've already given it the OAuth token, but it'll prompt you for your username and password if you leave that off. And then you just tell it what your build results are, and it's going to write everything that you need into your Travis YAML file. There's a cool tool that I talked about the other day in the DevOps Summit called Robo. And Robo is a task runner for PHP, but it also has a secondary role where you can use it to build really quick and fast command line tools. If you take a look at robo.li/framework, there's a little bit of a set of instructions there on how to quickly make a command line tool. And some of those instructions are reproduced here in the gray box. Down at the bottom, highlighted in yellow, there's a line there that says my.org/my-project. And if you fill that in with the GitHub organization and project name for your command line tool where your source code is stored, then Robo will automatically add a self-update command. So all you have to do is type my tool self-update, and it'll download your Phars from GitHub and replace the user's Phars with the updated thing. So you don't have to worry about making a distribution path for your users to get updates for your tools. This tool will do it for you automatically. Maintenance tasks. Maintenance is everyone's favorite chore, right? You do the same thing over and over and over again. This is an ideal area for automation, and I'm going to show how we can automate Composer updates so it runs every bit as well as this Leonardo da Vinci perpetual motion machine, maybe even better than that. We're going to schedule it with Travis Cron, and we're going to use a project called Composer Lock Updater, and I'm also going to show you a little technique to just auto-merge after the test passes so we can have really super automated updates for some tool or library. So this is the process we're going to use. Travis has a cron task that we can run daily, weekly, or monthly, and when this fires off, it just reruns a test, and we're going to have a test set up that will run the Composer Lock Update tool. This tool will use Hub to automatically create a pull request on GitHub, and GitHub will then automatically use the REST API for Travis to run your Travis tests, as every pull request already does. And when the pull request finishes, it will use the REST API to tell GitHub to merge the pull request. So here's an example of setting up Travis CI Cron. Unfortunately, there is no API to turn on cron at this moment, so you have to go into the web interface for Travis Cron and set your time period to daily, weekly, or monthly and click the add. And you'll see that once you've configured Travis Cron, it schedules the job to run in about a minute. So if you're testing Travis Cron and it doesn't work quite right, all you have to do is go and delete the cron schedule, create it again, and it'll run right away. So you can run through your tests and make sure that they're behaving correctly. You also have to add a GitHub token to the Travis settings, and you can see the URL here where you can just go to that URL, click on generate new token, and then you'll get one. Your token needs to specify scopes. Usually it's enough to select the repository scope, and then you will see a copy of your OAuth token. You can just copy it to the keyboard as to the clipboard with that little token there, and then using the Travis tool again, Travis envset GitHub token, paste, and you will write that environment variable into Travis so that when your tests run, it'll automatically happen. We want to prevent redundant execution. In my last presentation, I talked about highest lowest testing. So if you've set up highest lowest testing, you can add another environment variable that says something like do post build actions, and then when your script actually runs, you can test to see if that environment variable has been set. So if you're doing parallel tests across a lot of versions of PHP, only one of those will actually do the composer lock update. We also check to see if the Travis event type is cron, so that we don't do our cron tasks in our ordinary test runs. So in this example, we're using Travis and there's no Docker container involved. So we install the composer lock updater tool every time, and we're also installing something called the security checker Phar and the hub tool, because these are tools that composer lock updater will use to get this all rolling. Another very interesting thing about composer updates, if you're making a tool that works with a lot of different versions of PHP, something you need to watch out for is, say you have PHP 7.1 installed on your local system and you run composer update. A lot of times that will give you dependencies that won't run on PHP 5.6 or PHP 5.5. And then if you take that composer lock file and save it to your project and someone is using that older version and they try to run composer install, they're going to get an error and they're going to say, oh hey, now I need PHP 7.1 as well. So the way you prevent that is inside of your composer JSON config section, you make a platform section that says PHP, and you provide the version number that you want Composer to use when it's resolving dependencies. So now, with this in your Composer JSON, even if you're using PHP 7.1, you're going to get dependencies that work with PHP 5.6. So you can commit that Composer lock to your project and not run into any problems. Once all of this thing runs through, you'll see that the composer lock update tool automatically posts a comment to the pull request it makes. On the first line there, you'll see that the commit is created by a user called the update composer dependencies, the composer lock update user, and you'll have a little icon of the user whose OAuth token you use. Might be different than the user who created the commit. And there's some details here about what was updated. And finally, down at the bottom, it's using the Sensio security check report. And that will tell you if, before you ran Composer Lock Update, whether you had any components in your project that had security releases. So by reading this comment, you can see that it does or does not have security updates. and that can give you some indication about what priority you need to roll this out to production or back to make a stable release for the other clients of it, depending on what kind of a project it is. So that's kind of neat. Oh yeah, there's one more step here, and this little snippet, if you want to just take it and copy it into your Travis YAML file. After all of these things happen, if the tests pass, it'll say, oh, I'm going to take this test and I'm going to merge it back into the master branch. And so, if you're just maintaining a library or something like that, where going to master doesn't actually do a deployment, you can have relative confidence that it's not going to hurt anything if the tests pass and nothing changed in the PR other than the composer lock file. No one can really slip anything in there, because you can't add a new dependency without changing the composer JSON. And plus, none of this will run if it comes from a source that's not trusted, because your environment variables are not set by Travis if the source is external. So that all looks fun, but man, it seemed like it was kind of a lot of work to set up automating my automation. I don't want to do all of that work. So how about if we automate the automation of our automation? It's like the little Russian dolls. We've got automation inside of automation. So we can run a single command that will automatically configure Travis to do all of that stuff that we just talked about. Install it once. It's called ci.phar. And then all you need to do is change your working directory to a PHP project, define your OAuth token, and then you run CI Travis CLU, which means install the composer lock update for Travis, inspect the changes, push them up to GitHub. Then you do have to do the manual step of turning on cron, because as I mentioned, regrettably, there's no API for that yet. And then your final step is to be amazed. So the presentation is finished, but it's not finished because we're never finished. We're just going to keep automating. But again, please follow me on Twitter and find me on Slack. If you have any questions, I'm happy to help out at any time. And if anyone has any questions right now, I'm happy to field them.
So is this composer lock update process and all those tools, do you know if those work with the Drupal package repositories?
Yeah, it's going to just run a composer update. So as long as your project works with composer update, it will. And if you're using Drupal composer, Drupal project, then you should have a repositories section that points at the Drupal packages, and that will work just as well as any other composer package. And also, after I threw together this little prototype, someone mentioned that there was a service that does this. There's a free tier that you can just go to, and it's like Dependencies.io or something like that?
Dependencies.io.
Yeah.
It's an open source project with a cloud service, but it's a CLI tool that will do that for you and automatically create the workflows.
Yeah.
It also supports a whole bunch of other package managers.
Mm-hmm.
So, NPM.
Yeah, so, maybe look into that. Yes?
Question. So you have those examples around GitHub integration within PHP.
Right.
Are there any robo tasks available that do that you're aware of?
Yeah, Robo itself has a limited selection of tasks, and I think it only has GitHub. But for Pantheon, we have a tool called the Terminus Build Tools plugin, and at the moment it only works with GitHub and Circle itself, but we're in the process of expanding that tool out to also support Bitbucket and Bitbucket type pipelines and GitLab, and GitLab has both the repository and the testing service, and those are all implemented as robo tasks inside of the Build Tools plugin. And once Terminus supports plugins that have dependencies, then I'm going to take that and factor it out into a separate library. So then there will be another API where you can just code to a generic repository / test service API, and it'll figure out based on which service you're using which APIs to call. So you can do GitHub or Bitbucket or GitLab or whatever.
So there's no even third-party tasks that you're aware of?
No what?
Third-party, you've got like the Drupal.
No. There's like third-party APIs for most of the services, but they're very focused for each specific service, and there's a good reason for that because each service has only partially overlapping functionality. And so if you have an API that's focused specifically for GitHub or specifically for Travis, it does exactly the same thing that those do. And I did look into using those APIs as an underlayer underneath the uniform one, but it seemed too heavyweight. I didn't need all of that functionality. I was only interested in the intersection. So the API that I'm working is good for systems where you're not sure what your target is going to be, or you want to support a lot of targets, and you're only doing the minimum viable setup API. And if you actually want to have a wide control over just GitHub or just Travis, then you should go to the native APIs. And also the native APIs didn't seem to be very well suited for plugging. You could build an adapter layer on top of them with sufficient time, but it would have been a lot more time. So,
are there any cool Robo plugins that you're aware of, like the Drush one, for example, like the third-party plugins that you plug into Robo?
No, but Robo has a code generator to where you can make a task that pulls through to a project, and and as I mentioned, there's projects for GitHub and Travis, so you could easily generate a task with the task generator and be ready to go. All right. Well, if there are no more questions, I thank you very much for coming to the presentation. And it didn't freeze.